Hello and welcome to my first ever Microsoft Excel World Championship video. I'm Julien from Réunion. I'm a competitor in these challenges. And we had a nice case from Juan José Cifuentes, yesterday, and I wanted to show a creative approach on it, which is close of what I tried to do live. And spoiler, it was not the most efficient solution. Um, I will not tackle the whole case. I will just try to go on the levels where you can apply the creative logic. So basically, the case was about connecting some pipes. So you have these different pipes, and they were connecting, and you have this table with data where it says where you connect to or connect from. So let's take this one for example. You connect to the up, so you had a 1 there, and you connect from something that comes down, so you have a 1 in the second position. You connect from the left, so you have a 1 there, and you connect to the left, sorry, and you connect from right, so you had the 1 here. So it was basically up, down, left, right. And when I saw this, I instantly thought about bit logic. This is nibbles, half of a byte, and I will try to show you how I was trying to solve it live, basically, with some silly mistakes I made, because you can do this in Excel, but it's not the most efficient solution. But let's go. So I will go past level 1 because it was basically some index match and concat. We'll go on this level where it's the first time the BitLogic can apply. So I preloaded in the file my lambda collection. I made some preparation for the last level, so we can go. Hopefully, we'll be more efficient in terms of speed than what I did on the first day. So okay, so I will just load the value here. So I will load all the pipes. The connect from the table, and so I have the connect from representation of this pipe sequence. First thing we want to say is we want to check if there is a 1, so here in the least significant byte, on this pipe, and count them. But the thing is, Excel doesn't handle natively bitwise or functions with binary representation, because binary representations are considered as strings, and natively also Excel's, if your string is a number, it will try to convert it to a number. So basically, if I try to apply this to this number, it will try to apply it not to the representation of this number, which should be, if I do a bin to deck of this, which is 10, it will consider it as 1010, which is not what we want. So, and to match, to check if we have this bit in these nibbles, we will do a bit end. So we'll check bit per bit if there's a 1, or if this match our mask or our direction here. So we have this. So as I said, we will do a bit end, and we want to convert first the binary to decimal, and we will also convert the binary to decimal of our direction. And here we have some 1, 1, and so instantly I say, okay, I need to sum this, and that's what I did in the first time. and I will show you the result because that's all the silly mistakes I made during solving. And once I copied it, so you don't have the flag when you're solving live, and I said, okay, we have 5 pipes and I have a 6 here. So this can't be the good solution. And indeed, the thing is, the result we have, if I explode it, we have the byte where it will match. So if I want to use my formula, I will need to do something like sum of sorry, this is greater than 0, and this would work. Oh no. Sorry. What? Bit n, oh sorry, that's just a parenthesis issue. This would work. Okay. Hey, nice. We'll go straight to the last level, where I will force the bit logic there. This won't be at all the most efficient way. So I made some preparation there. I prepared the template for future data tables to have all the results. So that's what we have here. And I choose this game number because the example one was just a straight pipe, and it wasn't helpful because you have up and down, up and down. It was better to design the thing to have like a clear differentiation from one connection on horizontal axis and one connection on vertical axis. Let's go with this. So basically we have our start position, which is this one. Then, okay, I will use some row representation to grab everything from the map. I won't tackle this today. I mean, this is not the goal of this video, and I have my lambdas to tackle this, so I go faster on this way. So row of the start, which is the cell to row. Okay, then I have the direction. The direction is given here. It's this one. I will need to transform the direction to row, hence my small table here. So let's just do the XLOOKUP of the direction in the table and retrieving from the row column. Okay, so that's row of direction, and then we will reach the target row, which is the start plus the direction, and then we will convert this again to the target cell or address, and so it's G row to cell. Okay, and then we will need, finally, we will need to check what's in the cell 04 in our crazy pipe maze here. And so 04, so I want to retrieve this. So I was in 04, so I want to retrieve this one, N4. What have I done? Oh, we start in 05. Yes, that's good. Yeah, so again, I have some lambda for this. This in the map. Okay, now comes the bit logic. Okay, finally, symbol. So first we want to check where the flow comes from. Okay, the flow from that direction, and so we want to find the comes from for this symbol, connects from. Sorry. Okay, so that's the from. Then, as we know, we already used this bit here, we will have to remove it from the from. So we will need to mask the bit. To do this, we will use bitwise exclusive OR. Exclusive OR is just like when you have either 2 0 or 2 1, they would cancel out and you will end up with 0. It will only work if you exclusively have 1 on the two solution. That's what we are going to do. So we are going to have a masked from, and let's go. So we will need to convert everything, so the from, the direction, from binary to decimal. Then we will do our bit XOR operation, and then we want to retrieve, because it will be easier to show this visually, to put it back in binary form. So we'll start with the deck to bin of bit XOR of bin to deck of the direction and bin to deck of the from. And finally, as I always want to have my 4 digits visible, we'll specify it. Here it is. I remove the 1. Maybe not the most efficient, but I don't know. I'm satisfied with it. Then comes the next step. We want to change a from to a to. So basically we have our mask from, and now we want to have our next direction. Okay. So basically I know that it will be 0 0 1 0, because if I have a 1 here, I go back to the table, then it means that the flow comes from the left, so the direction is from the right, sorry, and so the direction is to the left. And it will be the same if I have up and down. They are going by pair because we have the horizontal and vertical axis. And so basically if we are here, we want to shift things right. If we are here, we want to shift things left. And same here, we want to shift either right or left on each axis. And so we have to find a way to say, okay, where is my current bit, and do I need to shift it to the left or to the right? And the thing is, as it is working with pair, we would need to check the bit position and to check its parity, because if every time the bit is on an odd position, we will go to the left, and every time the bit is in an even position, we will go to the right. So that's what the logic we will try to apply to transform our from to a to. So first we will need the position. To grab the position, we will use the binary logarithm, so logarithm in base 2. So we'll call the log function, and we'll use it on the decimal. So I will first need to convert my mask to a decimal value. Then we want to use it in base 2, so we'll call the 2, and that's it. And it tells us that it's in position 0, because the binary representation is first 2 exponent zeros and 2 exponent power, 2 power 0, 2 power 1, 2 power 2, 2 power 3, whatever. And so we just need to add 1 to have the exact position, the visual position, let's say. And once I have the position, I need, as I told you, to check. So I will need the parity. So let's check for parity of this byte. Again, I will use some bit logic, because you can basically test the parity of things with a bit end. So let's do this. Let's do the deck to bin representation, the binary representation. Oh, sorry, of this, and I want it in 4 bits. So yeah, every odd number always have the least significant bit, the 1 on, because you need a 1 to have an odd number. So if I do like bit end of of this with a 1, it would result as the same thing that if I would have done is odd of this. And is odd needs a conversion first. Okay, so it's the same. But I found it funnier to use BitLogic here. So we'll use our BitLogic. So bit end. And this one I have a decimal number, so I don't need to convert it with 1. So yeah, it's odd. And so then, as I mentioned earlier, I need now to shift the bits. And we have some function here in Excel to do this. So it's bit left shift, for example, if you want to shift everything here, let's say 2 bits to the left. Yeah, that's what I told you earlier. You first need to convert, but at least you saw it. So this was considered as a 1, as a 10, as an 11, as 100, as a 1000. One funny thing with bit left shift, it would be exactly the same as multiplying by 2. Every time you left shift, this is due to how the power is working, you multiply by 2, by 2, by 4, by a power of 2. And if you bit right shift the things, it would be like as a division, as a, how to say, quotient, supposedly, quotient of the number by exactly the same, so by 2, 4, 8, every power of 2. But here we will only need to move 1 bit. But just for you to know if you don't know this function. So we want to shift, we want to create our new direction. Direction here would be, so I have changed the parity, I will have either 1 or 0 here. So if I have this, I want to, so if it's odd, I want to bit shift to the left, bit left shift, or I would bit right shift if it's a 0. And what do I want to shift? I want to shift, I need to convert it. So bin to deck of my mast from to convert it to a 2, and I want to shift it by 1. And that's it. We have our new direction, and again I need to convert this to a binary form, so deck to bin of our result on 4 positions. And I have my new direction, and hopefully if everything is good now, my new start was my target cell, this I can just take it, the new direction is here, and then I can just, I think, go down here, and it looks good. And if I now take this, like not the cleanest way to do this, but okay. Looks like it worked because we reached the sync. So if I try to finish the solve, we will just make some if error of this. Yeah, that would be good, I guess. And we now just need to count how many banded pieces here we have. So, count ifs. Easy way. If in this, I will have this. That is not the cleanest solve I've made, but it would look a lot as how I will tackle this live. Yeah. And hopefully, yeah, that's it. Not that common way to solve an issue using crazy functions of Excel that you are not going to use every day, but for sure I had fun using them and pushing the logic and keeping it, trying to solve a bit of pipe. I mean PipeMare, but that was funnier. Thank you. I hope you enjoyed this. I loved it. If you liked it, tell me, like this video, add a comment to tell me how you what you thought about the video. Subscribe, because every time I will find a new creative way to solve some Excel challenge, I will try to share. Thank you. Bye bye.